We're given a triangle where it tells us that we're looking for theta. The opposite side is going to be 3 units long. The adjacent side is going to be 7 units long, and we know that the hypotenuse is the square root of 58. And we were asked to find these 6 trigonometric functions. So the first thing I want to do is let's start off by finding sine of theta. So if you remember, sine of theta is going to be equal to opposite over the hypotenuse. So if here is theta, we know that the opposite side is going to be the 3, so we're going to have 3 over the hypotenuse, which is going to be the square root of 58. Now the problem with this is we never ever want to leave a radical on the bottom of a fraction. So what we're going to do is we're actually going to go through the process of rationalizing the denominator. So to rationalize the denominator, I actually want to figure out, well, what would I have to multiply square root of 58 by to make it a perfect square? And of course that's also going to be the square root of 58. And of course if I do it to the bottom, I actually want to also do it to the top to make sure that we're multiplying by a factor of 1. So that's going to leave us with 3 on the square root of 58 over, and when you multiply the square root of 58 times the square root of 58, you get 58. So there's the sine of theta. Let's go on and do the cosine of theta now. So cosine of theta is equal to adjacent over hypotenuse. So if 3 is our opposite side, our adjacent side has to be the 7. So we're going to have 7 over the square root of 58. Now once again, this is not rationalized, so I'm going to rationalize the denominator by multiplying the top and the bottom by square root of 58. And when I do that, it actually ends up being 7 on the square root of 58 over 58. So that's our cosine. Go do tangent now. So tangent of theta is equal to opposite over adjacent. So we've already said the opposite side is going to be 3. The adjacent side is going to be 7, and we don't have to worry about cleaning that up because that's really pretty. So let's go do cosecant now. Cosecant of theta is going to be the inverse of sine, which just means we're going to flip the hypotenuse over the opposite side. And actually I can take it from this point right here where I had 3 over the square root of 58. If I just go through and flip that, I'm going to have the square root of 58 over 3. We've got the secant next. So secant of theta is going to be equal to the inverse of cosine, so it's going to be the hypotenuse over the adjacent side. So I can take it from right here, it's going to be the square root of 58 over 7. And then finally we want to find the cotangent, which is going to be the inverse of tangent, so we'll flip it where it's adjacent over adjacent over opposite, so it's going to be 7 over 3. And there's our 6 trigonometric functions.